Hello there, and welcome back to another day where I have some free time. And in this day's video, well, I kind of have deemed Nobita.h to be complete, and we just have to use it on some more projects to polish out the bugs and the features that I want to add onto it. So, to achieve that, I'll be starting a new project so that, well, I can learn how to do assembly even just a little. So I'll be trying to recreate the C standard library using inline assembly in C. So I guess I'm just gonna call that unstd-c since, well, we will be following the C standard, well, until I want to add more features to it. So let us get started. So unstd-c. Over here, I'll initialize a git repo, then rename the branch. Now let's get started for the README, where it's on standard C. And, well, what can be the description of this? A recreation, maybe, of the C standard library built on top of the, no, Linux Syscall and inline assembly. Yeah, I think that would do. Now for our to-dos, for our very first one is that, well, let's have a custom exit status. That's it for this episode. So to achieve that, we're gonna have Nobita over here. So gotta copy that over. Well, since we will not have our, well, any standard stuff over here, we cannot rely on the C main function yet, but I just gotta set this up for now for the blank daemon. So let us include this thing. Include nobita.h and the define nobita impl. Though maybe I made this compile flag a bit too early. So you gotta start that, as this looks like a pain. So void build. Now for our very first source file that will be put on test, and it's hello. Oops. Actually, I need to have the extension there. And we want an executable called hello Nobita build add target. Well, add exe anyways. B and name that hello. The build tool target set build tool is, well, GCC. The compile flags is the same thing that we put in the compile flags text file over there. So no standard includes and no standard library. Then for the link flags, well, nothing yet. Then we can add the actual source files. So hello, then test/hello. Let's see. And I think that should be it for now. Now for hello.c, now that we do not have main, as there's nothing to call on main, the C standard library does that. So the actual entry point is called start, but at least for I think the Linux elf files. Anyways, so what we want is a custom exit status, and we can do that with inline assembly. Though I do not know how to do syscalls over here. So let us call on the Linux syscall table for x64. And there should be something here called exit. Yes, there is. Sysexit with the error code. And I see 60 over here. What's that? So I guess we put that in the RIX register. And for the RDI register is the status code. So, hmm, well, let's see the ABI over here. That it does not exist. Huh. Let's see. Linux syscall ABI for x64. So let's see. What is the default calling convention on Linux? I think we're getting farther from the truth. So let's see. What is the default ABI of GC for Linux x64? There you go. I see the system V ABI over here. System V ABI for x64. So where do we go from this? Since, well, we just need to do syscalls over here. So GC inline assembly, syscalls. Maybe we can copy and paste this one. So let's see. I see an interrupt on hex 80 over here, but that's on 32-bit, I think. There you go, it's syscall. So Yeah, maybe we can copy that. So what we can do is, well, we have to move the variables first. So let's try it. Move 60 to RAX, and then uh move the number 0 to, was it RDI over here in the Syscall table? Yes, it's RDI. Then we can run Syscall over here. And I think the first column is for the variables where we write into. The second one is the variables that we read from. And the third one is the registers that we mess with on the inline assembly. So we have none of the first two, and I see that over here in the syscall itself, it, it messes with the RCX and R11, also with memory. So I guess we can try that out. So let's compile this build file, run it, and it seems to have completed properly. So the beta build, hello, it seems to have exited with 0. How about 69? Let's rebuild that, rerun it, and get the exit status. So it's 69. So we now have our custom exit status even without a C standard library. But, well, that's not what we're used to. I mean, having start as our entry function, but we're used to having main. So in the next episode of this video, we'll be having the C runtime. So make the C runtime object. Since, well, we gotta have something that calls on main. So thank you for sticking with me this far, and may I see you on the next one.